Okay, everyone. Assalamualaikum warahmatullahi wabarakatuh, and good day. For today, I would like to share about how to identify, or we call it quantification or quantitation of any compound concentrations, yeah, using the gas chromatography mass spectrometer. So, at the first place, when I prepare a video or when I record a video about this topic, how individual compound is identified by a GCMS. So there is some comment asking about how we can quantify or how we can determine how much the concentration of any compound in the sample using the GCMS itself. Because at the first place, when I record this video aimed to show to you on how to identify the compound that we have or we have extracted in one particular extract. Okay, so it's aimed on qualitative analysis only. So for today, I would like to share about how to determine or quantification or quantitate or having a quantification about the amount of concentration of that particular compound that we have identified previously. Yeah. So let me start and let me show about this one. Actually, for this topic, we would like to share, or I would like to share about determining the concentration of fatty acid methyl ester. So at the first place, I purchased the fatty acid methyl ester. So sometimes people call it FAME. So this FAME I purchased in the standard form, usually in the liquid form, or sometimes in the very concentrated form, which is they contain a fatty acid methyl ester of C4 until C24. So by purchasing of these fatty acid methyl ester, so I analyzed this fatty acid methyl ester using a GCMS. Okay, so the GCMS analysis can be carried out using the uh, GCMS mass spectrometer that we have in the laboratory, or sometimes in this case, in my laboratory, I have a GC12MS and gas chromatography time of flight mass spectrometer. So you may refer to this video to know about how this machine can be operated to determine or to identify the compound. But for this particular video, I would like to share that using this FAME, fatty acid methyl ester standard, we purchase this one, we prepare a dilution working standard dilutions up to a minimum of 7, which is the first one is a blend, and then and then the next 7 concentration is starting from the lowest one until to the highest concentration of fatty acid methyl ester standard, and then after we prepare the standard working standards, we analyze them using this gas chromatography time of flight mass spectrometer, or some laboratory they may use the gas chromatography mass spectrometer. Okay, to know about the differences between the GC12MS and GCMS, we will upload another video soon. Okay, so for this video, after we prepare this fatty acid methyl ester standard and then we analyze, we will get a result like this. Yeah? I would just want to share to you. So this one is I just name it as the 15 standard, which is the highest one. At the first place, I just prepare like 50,000 ppm of that oil, the fatty acid standards itself. So we will get this uh, 37 peak, yeah, or 37 which reflecting the 37 compounds. Okay, so uh, fortunately, by having this software, this is enhanced data analytics by the Agilent itself, okay, we can prepare a calibration curve within the software itself. Yeah? But at the end or another video, I will share to you about how to prepare a calibration curve and calculate the concentration of the sample using a manual Excel calibration curve. Okay, but for today and for this video, let me show you how to do it. So when we analyze, we will get this result. Yeah? So there is two windows that we can get here. The first one is uh, we call it a scan mode. Yeah. So this scan mode, you just analyze it, and then the standard, and you will get peaks. More than 37 peaks will be detected, including the impurities. Okay. But if when we conduct the analysis, we choose this theme mode, which is selected ion monitoring mode in the GCMS system, we can simply key in 37 mass of this fatty acid metal ester. This one, yeah. Uh, how to know it? Okay, usually when we purchase this theme, fatty acid metal ester standard, it will comes together with the certificate of the analysis. So you will see that there is uh, all these compounds are being mixed together in one ampule, and then based on this name you can identify or just Google to get the mass of individual fatty acid ester. So in this case, fortunately I have analyzed and then I have published a paper, a chapter of a book related to this 37 compounds. So this is the paper that I have published, yeah, effect of temperature on antibacterial activity and fatty acid metal ester of carica papaya acid extract. So you can go and then download this chapter in book, and then you can get the fatty acid metal ester 37 compound. So we have butyric acid, which is having assigned as C4 0 until 2. The 37 compound, which is I'm sorry. Okay, in this case, we have 38 because I have added another compound, fatty acid, which is not in the 37 compound. But the last one is cis 4, 7, 10, 13, 16, 19 docosahexaenoic acid, or we call it DHA. So the assignment is C22, C6 and 3. Okay, and then this is the mass that we have recorded for all the 37 compounds. But in this chapter, we added another one, which is 38 compounds of fatty acid metal ester. So this mass can be keyed in the GCMS or GC12MS, and then you will get this result, 37 compounds. So in this selected ion monitoring mode. So if we compare this scene mode and then the scan mode, you can see that the scan mode having a higher abundance, or yeah, abundance here. This is the y-axis, yeah, and compared to scene mode, so it's a lower abundance, but you can see it's more clean, or cleaner in terms of chromatogram, yeah, of the scene mode as compared to this scan mode. Okay, another advantage of having this scene mode, since we only key in those 37 mass only, okay, so only 37 compound will be detected, yeah, specifically on the particular mass that we have keyed in. Compared to this scan mode, anything that uh, were detected by the GC12MS will be shown in this form of chromatogram. Yeah, this is the scan mode. Okay, so for quantitation or quantification, I prefer to use this scene mode because it's very clean. And then it's very specific to the specific compound, because we have that particular mass. Yeah? That's why we call it selected ion monitoring. So that particular mass only will be detected using this C mode. Okay, so by having this, yeah, we can create a calibration curve. So in this software, we can just click set up quantitation. Yeah, so it will be asking you to reload current data file, so you can just say yes. Okay, so this is the calibration curve that I prepared previously. So in this video, I just want to share to you how to prepare as from the scratch, yeah, using this software. So I just put it theme scan and sim calibration curve. So today is 31st of March 2020. Okay, so I just leave it all these things here. Okay, the concentration that we prepared in the theme standard is ppm level, which is the unit is microgram per mil. Okay, but since this calibration curve does not include any internal standard, so that's why I just put 0 here. Okay, okay, so for this one, to continue about this calibration curve, so we start by opening the highest concentration file, the file with the highest concentration of fatty acid metaester standards. So, and then we can start to click setup quantitation. Okay, so I have prepared this calibration title name. So I put its theme scan sim calibration curve on the day. Yeah, and then you have to make sure that the concentration of the standard have been set up. So in this case, it is microgram per mil, which is ppm. Okay, but since this is not being added with the internal standard, so the calibration curve we will call an external calibration curve. Yeah, but later we might share about the how to prepare a calibration curve when we have an internal standard. Yeah. To differentiate between the external and internal standard, we'll be sharing in the next video. So in this case, we just proceed with the external standards. You just need to click OK. Okay, so you can see here at the first place there is no fatty acid being introduced to the system. So at the first place, before we set up the calibration curve, we need to introduce the 37 calibration standards. But for this video, I just want to introduce two fatty acid metaester standards. Yeah, so they will be including C6 and C8. So let us introduce first. So you have to click insert above here, and then go to open back the sorry. You just have to I'm sorry. So you have to open the 15 file. Okay, so in here you just go to this standards. So the first one is C60. Okay, so usually when you purchase standard from any supplier, you can check, you can get this certificate of composition. So by referring to all these certificate of composition, you can Google the mass of that particular compound of fatty acid. So in this case, I have published a chapter in book. So the C6 is at the retention time of 10.144 and the mass is 130. So you can see here at here 10.144. This is the C6. Yeah? So we have to tell the system this pixels belong to C6. So in this case, you have to zoom first, yeah? And then right click to the first to the highest peak here, right click until there is appearance of another window. So this window we call it max spectra window. So since we know that the C6 mass is 130, so you have to bring this cursor to this mass, yeah, 130, until there is uh, two white lines on the top and in the bottom of that square, yeah, until it's appear in the white form, and then you have to simultaneously click the left and the right of your mouse. So you can see here the target has been target mean the mass of the 130 for C60 has been introduced. Yeah, so even the retention time here has been introduced as well. So you have to click save. So after you make a save, you can see there is a we call it, there is a star, yeah, for this particular C6. Now I want to introduce C8 to the system as well. So you have to zoom again, and then bring your cursor to the highest peak of that C6A, and then right click, double click, on the right, sorry, on the left, sorry, on the right of that your mouse. I'm sorry for this one. So and then go back to check the CC8. The mass is 158 at the retention time of 10.940. So find 158 is here, yeah. So you have to bring, okay, you have to bring this cursor until it become white and then double click. Okay, before that you have to type the name of C80. Is it correct? Yeah. C80. Okay, correct. And then you can see here the retention time is 10.930. It's not that far actually. Yeah. 940 and 930. So you have to tell the system that these 158 is belong to C6 0 mask. So now the square having a white color line on the top and the bottom of it. So you just simultaneously click on the right and the left of your mouse until you get the target is 158.00. So now we have introduced two fatty acid methylester. So C6 and C8 have been introduced to the system. So you can proceed with the rest of uh, compound in this case. Yeah. So you can unzoom and then choose this one until the 37 compound. But since for this video is very short one, we try to just share to you about two compounds only. So if you want to proceed, you just click save, and if you uh, don't want, you have to click save and exit. So you just click save, and then here it will appear a new window. So you just click exit. Okay, so now two compounds have been introduced, which is C6 and C8. And then we need to prepare a calibration curve for for both of these compounds. So you just click exit. Okay, so file has been previously been quantitated, requantitated. Now you just click yes. Yeah, for example, this one. Okay, so now, okay, we want to add another uh, compound, which is the compound that we are going to add is the level of the concentration. For example, previously it's 50,000. Now we want to go to perhaps 25, or I just call it 25,000. Yeah, so the level is 2. Oh no, I'm sorry. We start with the lowest one, the lowest one in this case. So you have to go to the lowest one. For example, you know that in your, click cancel and go to check here. Okay, so 15,000, 50,000 is the highest, one of the highest. 16. So you can go to, I think, one blank. Number 10 is 5,000. Okay, for example, I want to use 5,000 as the lowest concentration. This is for an example. So we just click K here. No. Okay, sorry. Curve, cancel. So in this case, I just want to quantitate this one and then set up quantitation. You just need to click update, update one level. Okay, so 5,000. And then you can just choose level 1. Level is 1. Then click update to update. Oh, sorry. So just choose a different level. Okay, since this is the highest one, which is 12, you just go to 13, for example. So you just click due date and available to update. Okay, so you will get the C6 for that one concentration, the 5,000. Okay, so C8 as well. Okay, and then don't bother about this one because this is the previously been installed. So you just put the history record there. You can delete later. But the first concentration of 5,000 have been introduced. Okay, so now we want to add another a higher concentration. Okay, you just click OK. Proceed. Now go to the next concentration. Go to the load. So we have 11, which is 10,000 ppm. Click OK. Yeah. No. So you have to go to calibrate and then click update. Update one level. Requantitate now, yes. So this is 10,000 ppm. So you put 13 new level ID, which is 13, and then click to update. Oh, I'm sorry, 14. Okay, to update. So you will get 2 points now. Okay, 2 points now. Okay. Well, can we add more? Definitely. Just go, okay, and then I like to add more. So the previous one is 11. How about if we go to the 12? target is 15,000. Just click OK. So you will get this one. Go to calibrate, click update, update one level. Then yes, this is 15,000. Remember, so you have to type 15,000, and then it should be 15, the level now. Okay, to update. So you can see 3 points have been introduced. Okay, same goes to C6 and C18, C8. So C6 and C8. So again, for those who just make having some confusion, why only two compounds? Because at the first place, we only introduced two compounds of fatty acid metal ester to the system. So that's why only two calibration curves have been established. But in this case, there are 3 points of working standard, which is starting by with 5,000, 10,000, and 15,000. Okay. So you can see here 5,000, 10,000, 15,000. Okay. The rest can be deleted later because this is the history record from the software because I have prepared a previous calibration curve. But for this particular video, we try to add up to perhaps 7 or 5 to 7 peaks. Working standards so that we can see the calibration curve. Okay. So we only have 3 now. Let's add more. We go to number 13. Okay, so this is 20,000. We go to calibrate and then click update, update one level, quantity. Yes. Okay, so this one is 20,000. And then the new level is, this one is 16. Okay. So now we have 4 working standards. Yeah. Same goes to C8. Okay, you can see some deviation from there. You just click OK. Current changes will be saved. Proceed OK. And then you just open up another one. Go to number 14. Click OK. No. Cancel. Okay. Those are the history record of the calibration code that being established previously, and then click calibrate, update. Yeah. So those historical information shouldn't be boarding our video now. Yeah. Once it yes, and then this is, I think this is 14 is, oh, I think we have to check again. Sorry. So the data, this is 25,000. Okay. So this one, update, quantity should be 25,000. Okay. The level should be 17. Okay. So again, for this one, if you have some confusion why there is an existing level ID 4, 5, 6 until to 12 that been introduced previously, okay, this is actually the historical record as well. So if you have introduced it previously, you cannot use the same level ID, but you have to make sure when you want to make a calibration curve, you have to start with the lowest concentration. So in this case, we start with the I think 13, yeah, and then we move to 14, 15, 16, and the current one is 17. So the current concentration is 25,000 for now. So click to update. So you can see we have 5 working standards now. Okay, for both C6 and C8. Okay, then click OK. Let me check. Actually, I think we have run or analyzed 50,000 concentration. Yeah. Just click OK. So this is 50,000. Let's see. And then click update here. Go to update one level. Requantitate. So this is 50,000. You have to introduce this one into the system, and then level ID should be 18, and then click to update. So you can see we have 1, 2, 3, 4, 5, 6, yeah? And then 0. Okay, actually because we don't analyze any blank actually, so that's why it should be good in terms of calibration curve, because even if we don't run any blank, it's already reached to the 0 or intercept, yeah, of the y and x axis. Yeah? So you can see here we have prepared 1, 2, 3, 4, 5, 6. Okay, let me try if I can find another concentration. which is the higher concentration than 50,000? If yes, we can produce or continue to add another one. 16 here. Oh, I'm sorry. So actually, there is the last one is 50,000. Let me check. 17. Okay. So 50,000 is the highest concentration in this case. Okay. Okay. Now we can click OK. So let's go to the to the calibration. Yeah, calibration curve. Go to edit compound. So you can see we have two compounds here, C6 and C8. And then we have the calibration curve. And then we need to check whether there is a linearity for this calibration. We go to this tab, which is calibration. For example, we go to calibration. So you can see the coefficient of determination is 0.98, yeah, for C6. Yeah? And then for C8, we have 0.99, which is some satisfactory amount. Okay, but for information, for me, when I try to compare the calibration curve between mine, the one that I have established, and then whether it's being acceptable or not. Usually, I will compare to the other or previous published papers. So some papers mention that 0.98 is considered a good linearity. So we can assume in this video that the linearity for the C6 and C8 are acceptable. Okay, so now after having this calibration curve, we would like to know how to quantitate in the actual sample. So just click OK. Okay, for example, now let's see. I will try to open one sample. Okay, so usually in this sample, we can say, okay, for example, I have a biscuit that I have prepared or added some fatty acid. Yeah, so in this case, I have added a biscuit with some oil, and then I need to, or I want to identify how much the concentration of that C6 and C8 in this biscuit. So I just click OK. Okay, and then at the first place, I need to, we call it integrate first. So I need to integrate, and then since we are only using sim mode data, so you have to click file, select signal, and then untick the data.ms, just leave it data sim.ms. So only the sim data will be uh, delivered. So here we have to integrate again, okay, this one, and then you just click quantitate and click calculate, so you can get the results afterward. Okay, it's calculating. So you can see here, okay, so for C6 and C8, the response, or we call it the area of the peak, yeah, for this one is very low. Yeah, so for C6, we get the response of area is 82, and C8 is 3403. So the concentration is 118 ppm, and then for C8 is 8719.10 ppm. So in this case, we have able to identify the C6 and C8, and then we able to quantify or to determine how much the amount of C6 and C8 in the biscuit that being added with the oil. Say, okay, for example, I have another sample. I try to have, for example, another biscuit at different concentration of oil that being added to this biscuit. I extract the biscuit, I extract the oil from the biscuit, and then I try to quantify how much is it. So again, go to file, choose select signal, just click or allow data sim to be displayed, and then click OK. So afterward, you need to integrate. In this case, integrate means the system will identify the we call it the retention time for all the peak that being detected from the sample. So from here, we can get this 14.30, and then some of the compound being there. Maybe it's very low, but we can even identify or quantify how much the amount of C6 and C8 from the sample. So after we integrate, and then we have determined the retention time, so we just go to quantitate and then click calculate. Okay, so this is another biscuit at different concentration. So you can see the C6, we get a response of 78, response mean the area, peak area, and then the C8 is 2752. The concentration is 74.64, and then the concentration for C8 is 6968.07 ppm. So uh, this is the end of our video. It's actually quite long, but for in the next video, we will tell you about how to even quantify the C6 and C8 of the fatty acid using a manual calculation, but still based on the result of the GCMS. Okay, so see you later in the next video. Assalamualaikum and good night, everyone.